Hi, I'm Toby Mester from data36.com, and this is the first episode of my SQL tutorial series. Or actually, there was one before already where I showed you how you can install PostgreSQL and SQL Workbench so you can learn and practice SQL. But in this video, I will actually show you how SQL works in practice, how you can write an SQL query, and so on. I will start from scratch, so if you have never touched coding, programming, or SQL queries before, that won't be an issue. And as I mentioned, this is going to be a series, so in this first episode, I will start with the basics, and in the next episodes, we move towards the more and more complex SQL concepts. Before we get started, a quick comment on how I recommend using this SQL tutorial video so you can learn SQL in the most efficient way. Well, first off, I think that SQL is relatively easy to understand and use, but just by watching this tutorial, you won't learn it, I can guarantee that. Don't worry, I got you covered, and here's the two-step plan to get the most out of this learning experience. Step 1, you go ahead and watch this video. You don't have to do anything, just go through it, watch it, process it. With that, you will see how SQL works, what do I do in it, and why. And then step 2, I link the article version of this video in the description, and I really recommend that you continue there. This article lists the full code base that I used in this video, with explanation of course. So after watching this video, I encourage you to check out the article and do the coding part for yourself too. Watching someone code and writing code are two completely different experiences. And if you want to actually learn and use SQL, you should write the code by yourself. Okay, let's get started. Okay, so what is SQL? Well, SQL stands for Structured Query Language, and it is used to communicate with relational databases, but I like to describe it as Excel on steroids. Here's the very same dataset in Excel and in SQL. And as you can see, SQL and Excel are quite similar. Both of them present the data in a two-dimensional table format with rows and columns. Both are very structured, very transparent. However, there are differences as well. There are two major things that you should know as a beginner in SQL. The first one is the performance. While Excel is great with smaller datasets, it becomes really slow and inefficient when you use different complex formulas, for example, on a file with 100,000 rows or 1 million rows. In SQL, even 10 million rows or more can be processed fairly quickly. For instance, in the upcoming episodes of this SQL for Data Analysis tutorial video series, we are going to use an around 7 million row big dataset. The second is how you can access your data. Excel is primarily a graphical user interface. You can scroll, type your formula, select your range with your cursor. Very handy. In SQL, you don't have this interface. You have to type so-called SQL queries instead. At first, this can feel like a hassle, but believe me, once you have understood the basics of SQL, you will find it clearer and more efficient than Excel. Here are just two advantages. Joining tables is much easier in SQL than it is in Excel, and automating and reusing your code will become more convenient with SQL too. When you use SQL for data analysis, you will use it most probably for simple tasks, aggregating data, joining datasets, using simple statistical and mathematical methods, but you will be able to do this more efficiently and on much larger datasets than before. And a quick question, what about Python or Pandas or R? And as an aspiring data scientist, you might ask, is SQL better or worse than Python or Pandas or R or Bash? And the answer is, well, there is no answer for this question. Once you start to apply these languages on real-life analytics projects, you will see that Python, for instance, is good for some things and SQL is good for other things. The main difference will be the syntax, the different features, and the performance, but I really don't want to go into that topic right now, because that's a bit more advanced topic anyway, and you don't have to worry too much about it right now. Okay, let's get started with the coding. As you can see, I've just opened SQL Workbench and my connection details to the remote server where I run my SQL database are already typed in. We have done this in the previous video where I've shown you how you can install PostgreSQL on a remote server so you can practice and learn SQL. If you haven't watched that video yet, I'll link it in the description. Anyways, the connection profile is already there, so I will just click OK, and with that, I will log into my server. Okay, I have connected to my database, and this is SQL Workbench. Basically, we have quite a few things here, but the first and most important part is this window where you can write your actual queries. I will explain this soon, but the point is that here in the statement window, you can write and run queries. And there is another important window, the Database Explorer, which you can find in the Tools Show Data Explorer menu. And this Database Explorer window is really important because this shows all the SQL tables that you have on your server, or more precisely in your SQL database right now. And for me, this is only this test data table that I created in the installation video. So I go back to the statement window, and my very first step will be to get some data that we can work with. And for a start, we will use a really small data set called Zoo, and you will find the link for it in the article that I mentioned at the beginning of this video. But we will just really quickly create a table and load some data into it. And I won't explain this here because creating a table is a more complex SQL concept, and I don't want to start there. So if you are doing the article, just copy paste these two SQL commands from the article. The first one is the create table, and the second one is the insert into command. And we will just run both of these commands. Again, right now, you don't have to know what's going on here. Just copy paste this, and I will explain this later. One more SQL Workbench thing that you should know about is that you can run a query by actually clicking into the query anywhere and clicking this second button, the execute statement at the cursor location button. It's like a little play button. This created the table. I click to the second query. This inserted data into the query. And done. From this point on, I can work with the new SQL table called Zoo, and we will do that in this tutorial. Okay, one more thing here. You will actually have to type here one more command, which is commit, and running this one as well. This one little command actually pushed the changes, the table creation, and the data load to our data server. So we actually saved these changes to our data server. Anyways, this was the most technical part of this video. And now let's start to write queries. Okay, I deleted this. And it's time to learn the most essential SQL statement. And this is select everything from table name. And you will use select every time you want to get read, filter, transform, aggregate, or do anything with your data in SQL. And 90% of the things that I will show you in this tutorial series will be sort of the modification of this single query. So, of course, this won't be table name. It will be the actual name of the table. So, in our case, we will select everything from Zoo. Pretty nice. There is our freshly created SQL table. We have all the columns and all the rows printed to our screen. And before we move forward, I want to quickly explain what's going on here. Maybe it doesn't even need an explanation, as the syntax itself is really close to English language, but just in case, select is the main statement, and it tells SQL that we want to read something from our table. This asterisk character, or this little star, usually refers to everything. In this case, it means that we would like to select every column. From tells SQL that we are going to specify a table from which we want to retrieve the data, and zoo is the name of the table itself. And of course, you can replace this with any other table name if you have more tables. Like for me, I had another table called test in my database. And one more thing, the semicolon. And this is an SQL specific syntax, but you will have to use it, and you have to know that every query should be closed by a semicolon in SQL. If you accidentally miss it, SQL will expect you to continue your query and won't return anything to your screen. So don't forget the semicolon, and remember this general query. You will use it a lot from now on. Okay, the next thing to learn is how to select specific columns. And as I said, this asterisk character refers to everything, more precisely every column, so you can replace it with actual column names. Try this query, for instance, animal, water need. Select animal, water need from zoo, semicolon. Let's run this. So pretty much what we have expected. You got two columns on your screen, animal and water need, but not the unique ID column anymore. Well, this way you can select any columns. You just have to specify the name of the column separated with commas. You can do something like animal, animal, animal 2, although it makes no sense, but just in case, it will return the animal column 3 times. Well, usually we do things that make more sense. Animal, water need, that's it. Or animal, unique ID, whatever. It will return the given columns. Okay, the next thing to learn is controlling the number of rows printed to our screen, and for that we will use the limit clause. And right now we are working a data table of 22 rows, but in the next episode of this video, as I mentioned, we will use a 7 million row big data file to do more advanced analytics. And in that case, it will be more than reasonable not to print all your data on your screen every time, but take a small sample of the first few lines instead. And to do this, you use the limit clause, which is a small extension on the top of our query. For instance, you can type something like this. Select animal, column, unique ID from zoo, limit 10, semicolon. Let's run it. And this will print the first 10 rows only. Now, of course, you can change this to 5. And of course, you can print all the columns, but only the first 5 rows. So, yeah. And this is where it starts to get exciting, because you can select specific rows based on values in specific columns with the where clause. For instance, you can type something like select everything from zoo where animal equals elephant. As you can expect, this will return only these 3 rows, but let's run it. And indeed, this is what happened. And so select everything from zoo is just our base query. Where is an SQL keyword which tells SQL that you want to filter for a given value. Animal is the name of the column where you are looking for the given value, and elephant is the value itself that you are looking for in that given column. And of course, never forget the semicolon. Okay, so far we learned 3 basic SQL concepts: the base query itself, the limit clause, and the where clause. And in the article format of this video, you can find a mini exercise where you can test yourself, which will be select the first 3 zebras from the zoo table. The solution of this mini exercise will be more or less the summary of everything that we have talked so far. I won't tell you the solution here, but you can check out in the article in the description. And instead of that, let me continue and let me talk about 2 essential syntax-related SQL requirements. So the first one is the thing that I have already mentioned, but I see people who are just starting off with SQL forget about it all the time, and that's the semicolon at the end of each query. So just to hammer this home, all your queries should end with a semicolon. If you accidentally miss it, SQL will expect you to continue your query and won't return anything to your screen. So this is not good. This is better. And the other syntax thing that I want to talk about here is the case sensitivity of SQL. And by default, SQL, and more specifically PostgreSQL that we use here, is not case sensitive when it comes to SQL keywords. So if you want to, you can change this to select from where and run it, and it will just run. And interestingly enough, the case sensitivity of table names and column names won't be an issue either in our current setup. So this will run too. The only thing that's really case sensitive is the actual value from the table. So for instance, this elephant value is case sensitive. Elephant. See, it doesn't find anything in our table that equals to this value because this is with all caps. But if you change it to small letters, it will return the 3 rows that we expect that it will return. So anyway, the rule of thumb is that anything between apostrophes is case sensitive, the rest is not case sensitive, but the best practice is that you use the SQL keyword with all caps, from, and the table and column names I usually like to use as lowercase letters, but it really depends on your best practices. Okay, as a next step, I want to go a little bit deeper into how this SQL where clause works. And as you can expect, with where you can do more than something equals something. It can be greater than, less than, not equal, less equal, and so on. And here's a short list of the comparison operators that work with the SQL where clause. You can find the same list in the SQL tutorial article that I mentioned and linked in the description, and also in the SQL cheat sheet that I linked in the description as well. Anyways, let's see some concrete examples. So, how would you select all the animals that are not zebras? I would do something like select everything from zoo where animal is not zebra. So usually in programming, not equals is this exclamation mark equals syntax, but it can be, well, first of all, I will run this. So, okay, this is everything but zebras. It can be this as well in SQL. So this works just the same way as exclamation mark equals works. I prefer this one because this is the same in Python as well. So it's better to learn this one. Anyway, the point is that you can do not equals, you can do less than or greater than. So for instance, how would you select all the animals for whom the water need is less than 300? So this column is less than 300. I would do water need is less than 300. Just like that. Okay, and there is our result. Mostly zebras, but that's fine. Anyways, I think you get the point. So take this to the next level. There is another operator called like. It's similar to the greater than, not equals than. So to these operators, and it's good to select patterns. If we go back to our full table, select everything from zoo, maybe we will want to select animals that contains the letter E, right? So elephant, tiger, and zebra, but not lion, not kangaroo. But our task is selecting all animals whose name contains at least one E character. We can do that with the where clause and with the like operator. So we are looking for the rows where in the animal column we have something like E. And of course this won't work because it has a special syntax. First of all, this goes between apostrophes, and we have to do something called wildcarding in SQL. More specifically, for this given task, we will have to use 2 percentage signs at the beginning and at the end of the pattern. And this means that this E character can be anywhere in the word. So elephants, tigers, and zebras are returned, but not kangaroos and not lions. And what happens if I remove this percentage sign? It will return elephants only, because it means, this percentage sign means that our pattern looks, in this case, E and then anything. If this would be our pattern, it would mean anything, E, and anything. So I hope I managed to explain this clear enough. But if you don't put the percentage sign at the beginning, that means that before the E, nothing comes. So that's practically the first letter of the word. And after that, anything can come. So that condition is fit only by elephants in our data table. Or you know what, maybe I will show you any other example and you will get it. So this anything roo would mean kangaroo. There is another wildcard character, the underscore. And while percentage sign means any string of characters of any length, the underscore means any character you want, but only one. So in our case, kangaroo would be something like this: 1, 2, 3, 4, 5, and then roo. This is a kangaroo. Zebra would be Z underscore A, zebra, but it could be C. So how is this useful? Most probably you won't query this Z underscore B underscore A from your table, but it's good for answering questions like, how would you select all animals whose species name is exactly 5 characters long? It would be 5 underscores. So 1, 2, 3, 4, 5. Let's run it. And it's tigers and zebras, right? Anyways, this is how the where clause works with the like operator. And the next thing that I want to show you is how you can combine different conditions in an SQL where clause, or in other words, how you can add more of these to your SQL query. And as you figured, you can combine conditions with logical operators. There are more, but here I will highlight the 2 most important, and or. And let's say that we want to select all the animals whose name is exactly 5 characters long, except for tigers. That means that we have 2 conditions, and we can do that with SQL where, boosted with the AND logical operator. I can keep this and add AND animal is not tiger, like that. And so what I expect is that tigers will disappear. And that's what happened. So zebras only. Okay, I can twist this a little bit more and select only those animals that have a name exactly 5 characters long, are not tigers, and have a water need more than 200. So that will be, and water need is greater than 200. And if I run it, boom, there you go. So as you can see, you can use multiple AND operators. And just in case, here is a little SQL Workbench trick. If you want to, you can right-click your query and say reformat SQL, and then it will break your SQL into a much nicer format. It removed my semicolon. I will put it back. So this is a much nicer format of my SQL. And because of the semicolon at the end of the query, you can break your SQL query into multiple lines. SQL will still know that this is one query. And as I said, because of the semicolon at the end. So don't worry too much about this. By the way, we will get back to formatting at the best practices video, but I like better this way, my SQL query. So I think this is a bit nicer, but you know, that will be just fine. Or actually, some people use it this way, even more structured. We won't need that. Instead of that, let me show you the OR operator. So right now we are using 2 AND operators, but we can use an OR operator. And as I said, it's pretty close to English language, so I will give you one example, for instance, where water need is less than 300 or animal is lion. What we expect here? I expect exactly what's on the screen. I expect animals from my table who has a water need less than 300 or lions. Let me run this. And that means that we will have lions, all the lions, even if their water need is above 300, but we will also have animals whose water need is less than 300, but not lions. And I hope that you get the point, and returns every row where all the conditions are true, and or returns every row where at least one of the conditions is true. And before I finish this video, let me show you two more not so frequently used but practical operators. The first one is the SQL in operator, and here's a quick example. I want to select all the animals whose unique ID is 1001 or unique ID is 1008 or unique ID is 1012 or unique ID is 1015 or unique ID is 1018. That's a lot of typing, maybe way too much, and there is a shorter way to get this done, which is unique ID in, and then we just have to list all the IDs one by one between parentheses. And we don't have to repeat the unique ID, which is there already at the beginning of the where clause. And this will return, of course, the very same result. That's the SQL in operator, can be really practical. And there's another one that I wanted to show you, the SQL not operator. And let me bring back this query where we queried the 5-character long animal names or animals from the table, where animal like and 5, 1, 2, 3, 4, 5 underscores. That means 5 characters. That means tigers and zebras. Now, how do we select all the animals that are not 5 characters long? And the easiest way to do so is just typing here not, which will return the opposite of what we have on the screen: elephants, lions, kangaroos. Simple as that. Okay, that was it for today. As I said, this video was about the most basic things in SQL, how you can query a table, how you can select rows and columns, and we have used a small dataset with only 22 rows in it. But in the next episode, we will go deeper. First off, we will create a new table and import 7 million rows of data to that table. And I will also introduce the basic SQL functions like max, min, sum, count. Plus, I will also show you a few more important clauses: order by, group by, distinct. It will be all very exciting. And by the way, who knows, when you are watching this video, maybe it's already uploaded. And if so, you will definitely find it linked everywhere around this video, top right corner, description, and cards, and so on. Anyways, this is the end of this video. If you liked it, please leave a like, or even better, a comment. If you want to learn more about SQL, you have quite a few options. First, as I said, I really encourage you to check out the article version of this video on the Data36 blog and do the coding part yourself as well. 2, I've also created a free SQL cheat sheet that you can download by subscribing to my newsletter at data36.com/newsletter. And if you want to be absolutely confident with SQL, you can check out my 7-day 0 to intermediate level SQL online course as well, where next to the tutorials, I added many tasks for practicing as well. Anyways, thanks for watching. I'm Tomi Mester from data36.com. Until next time.